Arc length and central angle measure. All right. So this is like a huge divergence from the previous topics. It's one of the weird things about this section. It contains so much, but a divergence from the previous topics, but still using radians. Um, let's look at a circle. We'll be looking at a lot of circles this semester. Arc length is an arc. It's just part of a circle. That's an arc. If it's part of a circle, it's an arc. And like label that thing right there as an arc, and it has length, and that's what we call arc length. So however long this little piece of string is right here, that would be arc length. And then central angle is referring to whatever angle right here is giving us this intercepted arc up here. So this guy right here is our central angle. There's a formula for finding arc length, and the formula is S is equal to R times theta, where, and this is important, theta is measured in radians. The formula is different if theta is measured in degrees, so I'm only going to give you the formula if it's measured in radians. Switch it to radians. If you're in degrees, to go from degrees to radians, you multiply degrees by pi over 180. And that will give you the formula in radians, or the degrees, the angle in radians. All right, so I'll just do one example of these. They're all a little bit different, but they involve the same general setup, a few differences. But a circle has a radius of 5 meters. Find length S of the arc intercepted by a central angle of 125 degrees. Do not round any intermediate computations. So because my angle was given in degrees, I have to switch it first. Switch to radians. If you're in radians to begin with, then you do not need to do this. So 125 degrees times pi over 180 degrees is what theta is. So you can put this into your calculator. Now, if your calculator will give you a decimal number out of it, if they won't keep the pi involved, then just do 125 divided by 180, which is what I did on a calculator just now. And you'll get 25 over 36. So 25 pi over 36. Or you could just leave the stinking thing. Why not just leave it? Just leave it as 125 pi over 180. That's what your angle is. That's the angle. Boom. All right. The last thing I need is the radius, which, hey, that was given to us, yeah? Right, radius here, radius of 5 meters. So R is equal to 5. Theta is equal to 125 pi over 180. So arc length, S is equal to R times theta. That's 5 times 125 pi over 180. It's really important that you don't do any intermediate rounding if you're not told to. So this says do not round any intermediate computations. That intermediate one would be this one here. So if you took this number, put it into a calculator and got a decimal out of it, and then use that decimal over here, you might get the wrong number. So that's what it means to not do any intermediate rounding. Now I can round to the nearest tenth, so I'll go ahead and put that on a calculator real quick. All right, and my calculator is coming up with 10.9. Is that what it said? Yes, 10.9, yep. 10.9, and this is a distance. Length is a distance, so units are just meters. Sometimes questions might ask you to just to plug in the numbers like we did here. Other times you might be given arc length and asked to solve for radius or for theta. But those aren't any big deal. You're just doing a tiny bit of algebra after you plug in on this step right here. All right. Next, and I think last, oh no, 2 sections left. Next section will be area of a sector of a circle, and I'll see you in that video. Bye.